Lesson 9.5 is all about symmetry. This is one of my favorite topics because it's something we've been doing for a long time. Think back to when you were in kindergarten. You learned about symmetry. So we're going to take this concept just a little bit further this year, and we're going to talk about some different types of symmetry. The first type is line symmetry. This is the most familiar type, and what this type of symmetry is a figure can be mapped onto itself by a line. Take our little starfish friend over here. If we were to draw a line down the middle of this starfish, you could see the left and the right sides are the same. But it doesn't just have one line, it has a line through each one of the starfish's arms. So if you count that, you have a total of how many lines of symmetry? Well, it has 5 arms, so it has 5 lines of symmetry. Let's talk about rotational symmetry. This type of symmetry is a little less familiar, but we call it radial, and that's when you rotate it. If I rotate my paper like this, it doesn't look the same anymore because it's been changed. But if you rotate a figure and it does look the same, that's rotational symmetry, and you have to rotate it between 0 and 360 degrees for it to have rotational symmetry. Now, when you hear the word order of symmetry, when we say order, we mean the number of times a figure maps itself as it rotates from 0 degrees to 360 degrees. And lastly, our last vocabulary is magnitude. Now, this is different than magnitude of a vector. We're talking about symmetry here. So the magnitude, think about the angle, and it is the smallest angle through which a figure can be rotated. So on some of these, yes, you could rotate it several times and it will look the same. We want to look at the smallest, the first time you rotate it and it looks the same. So let's try some of these. Example 1. Let's look at our star friend first. If I rotate my paper, will my star look the same with the point facing up? If I rotate it like this, does it look the same? Yes. So we can confidently say that this star has rotational symmetry. Where do we rotate it? Well, we rotate it about the center. So center of star is where the center of symmetry is. Now the order. Well, we have here 1, 2, 3, 4, 5 points. So if I think about the order, I want to try to find this angle right here. So I need to divide 360 by 5. What is 360 divided by 5? It is 72 degrees. That is the order, or the magnitude. What is the order? The order is the number. So 1, 2, 3, 4, 5. Let's look at this wavy shape over here. If I rotate it, will it look the same? Let's rotate it. No, not yet, not yet, not yet. Hey, now it looks the same. So we rotated the paper upside down. So yes. And the center of symmetry is also the center of this shape. What is the order? How many times did we have to rotate it before it looked the same? Well, you can rotate it upside down. That's 1 time. And then right side up. That's 2 times. So the order is 2. So the magnitude is 360 divided by 2, which is 180 degrees. All right, let's look at this plumeria down here at the bottom. We want to look at when will it look the same? Yes, it has rotational. The center is the center of flower. What is the order? How many times will I rotate it? 5. Very good. What's the magnitude? Yeah, it's the same as our star, 72 degrees. That means this angle right here is 72 degrees. Okay, let's look at this gear over here. It definitely has rotational symmetry. And the center is still the center. So let's talk about order here. We've got 1, 2, 3, 4, 5, 6, 7, 8. So the order is 8. What's the magnitude? Yep. It's 45 degrees. Okay, turn it over. Let's look at some real life examples here. Does this first kaleidoscope image have line symmetry? Yes, it has line. Now let's find all the lines. Most popular is straight up and down, and horizontal left to right. But now, are there any other lines? Yeah, there's this line right here through corner to corner. And then there's this line over here, the other corner to the other corner. So how many lines of symmetry does it have? It has 4 lines. Let's look at this. This is a famous structure in India called the Taj Mahal, and the builders actually built it to be symmetrical. And if you notice, if you draw a line straight down, each side is perfectly symmetrical with the other. It was actually created to be that way. So yes, and it has 1 line of symmetry, 1 vertical line. The cool thing about symmetry is you can look all around you, and God designed so many things to be symmetrical. Think about our bodies and nature, like this leaf, this maple leaf, as intricate as it is, if you draw a line straight down, each half of that leaf is perfectly symmetrical. I don't think that happens by accident. So yes, 1 line. God created all of it to reflect Himself. Plane symmetry. All right, you're going to have to be creative here. A figure that can be mapped onto itself by a plane, because we're talking about a 3D figure. So think about a piece of paper. Okay, I know you're not artists, but that's okay. I'm just going to kind of draw a piece of paper, cutting it in half. All right? You can see that each side of this is the same, so it has plane symmetry. Axis symmetry is a figure that can be mapped onto itself by a line between 0 degrees and 360 degrees. Okay? So I want you to draw a cone and dot the back, so 3D cone. If I took a line and put it through the middle, and I rotated it, it would look the same no matter how I rotated it. That's rotational symmetry on a 3D figure, which we call axis symmetry. Okay, example 3, plane symmetry. Does the ball have plane symmetry? Yes. If I stick a pole through the ball, will it rotate and look the same? Yes. So this has both. What about these flip-flops? Doesn't really have axis symmetry, but it does have plane. Okay? So that's all for your notes. Please notice the back page of your notes that has the concept summary. Look over all of these shapes and terms so that you know them. Line symmetry, rotational symmetry, plane symmetry, here's a better picture for you, and axis symmetry. Okay? There you go.